Greetings, fellow mathematicians! We're going to take a look at our third problem on finding a derivative using the limit definition, but this one is going to be a lot more complicated because the function is a fraction. F of x equals 1 over x. Many Calculus 1 students struggle with fractions, so we're going to take our time with this one. Now, like the previous problems, we're going to apply in this video both equivalent versions for the limit definition of the derivative. We're going to start with the first one, and we're going to use a tip from a video that I have linked down below in the description, where we'll use the tip of starting. Let's just rewrite the function, replacing all x's with open parentheses. If you haven't checked that video out, definitely do so before going through this problem. All right, so let's write the function here. As that. And that's going to be our reminder that whatever we plug in for our function, well, because the x is in the denominator, we're going to be plugging in that denominator, a plus h. And that is typically where students might get stuck. The other place where they'll get stuck, because the function is a fraction, is in step 2. We're going to be subtracting fractions with different denominators. So let's get to all of the specifics here. For the first step, where we're using a as 4, we're going to calculate f of 4 plus h and f of 4. All right, this is pretty simple. We're just going to plug in to our function 4 plus h, so we'll get 1 over 4 plus h. And there's nothing we can do to simplify that, nothing to expand or multiply out. And we just plug 4 in to the function, we'll get 1 over 4. All right, step 1 is easy. Now we go to step 2, where we're going to be subtracting them. And this is where all the work occurs for this problem. Because we're going to be subtracting fractions with different denominators, we're going to need a common denominator. So let's write this down, f of 4 plus h minus f of 4. And we're going to write that as 1 over 4 plus h. That's your value here for f of 4 plus h. And we're going to subtract 1 over 4, which is f of 4. Now, one of the tips, again, which we have linked down in the video below in the description, is to use parentheses around that value that you're subtracting, but since f of 4 is positive 1/4, we don't need those parentheses. So we'll just write minus 1 over 4. And we're going to combine these fractions together using a common denominator. And that was one of your algebraic tricks for eliminating indeterminate forms with limits that give 0 over 0. All right, our LCD that we'll be using here is you can just multiply those two denominators. So we'll write that as 4 times 4 plus h. And we're going to have to multiply and divide by missing factors. Again, we're going to take our time with this, since many Calculus 1 students kind of will struggle right here, working with fractions. So let's take the first fraction, 1 divided by 4 plus h, and to get this least common denominator, we're going to need to multiply and divide by 4. All right, now we go to the second fraction, which is just minus 1/4. And to get that LCD, we would need to multiply and divide by the missing factor, 4 plus h. All right, at this point, you should now have fractions with common denominators, 4 times 4 plus h. Now, we can just go ahead and subtract the numerators now, and be careful to use parentheses, because we're going to be subtracting something with several terms. So let's write this as the denominator, 4 times 4 plus h. And now if we go ahead and subtract the numerators, we have 4, but minus, and I'm using parentheses, 4 plus h. Very common mistake is made right here in not using parentheses, which is one of the tips that I can give for students in the calculus sequence. So just put a set of parentheses there, anywhere after the minus sign. That should fix a lot of common sign errors. All right, now this should simplify. If we go ahead and open up the parentheses, distributing the negative, we'll have 4 minus 4 minus h, and that's all over 4 times 4 plus h. The 4's cancel out, and what we're left with is negative h divided by 4 times 4 plus h. And that is it for the second step, subtracting, which is most of the work applying this first version for the limit definition of the derivative. All right, now again, in the video linked down below in the description, we have another tip which is relevant here because our function is a fraction. If we were to take this, which that result from step 2 is itself a fraction, and then we divide by h, we're going to have fractions within fractions. The tip that we use to get around that is instead of dividing by h, which is step 3, we're going to multiply by 1 over h, the reciprocal. So think of that as being equivalent. Dividing by a quantity is equivalent to multiplying by its reciprocal. All right, so we go now to step 3, and we have f of 4 plus h minus f of 4. And we're going to write that in general as dividing by h, but I'm going to write the division by h on this side to actually simplify. I'm going to write that as multiplying by 1 over h. And what we multiply by 1 over h is the numerator, which we just simplified as negative h divided by 4 times 4 plus h. And notice now it's much more obvious that those factors of h can cancel out. And what we're left with in the numerator, when things cancel out completely, you're always left with 1. So this simplifies to negative 1 divided by 4 times 4 plus h. And that is almost all the work. We just go now to our final step, step 4, which is taking the limit as h approaches 0. So if we write that down, this is us calculating f prime of 4. And we take a limit as h goes to 0, using that expression that we just fully simplified, which is negative 1 divided by 4 times 4 plus h. All right, and it's important to point out the moment at which the indeterminate form cancels, that is right here. H being multiplied by 1 over h, they cancel out, and that allows us at this point to evaluate this limit basically by plugging in h as 0, since there is no more indeterminate form of the type 0 over 0. So if you just plug in h as 0 here, looks like we get negative 1, and then 4, and then in the parentheses, we have 4 plus 0, which is 4. So it looks like what we get for our final answer, which that's the answer for the derivative, the slope of the tangent line, that comes out to negative 1 over 16. And that's it. So part A is complete. We just calculated the derivative of this function at 4, And that came out to negative 1 over 16. All right, now we can write down for part B the equation of the tangent line. And the general form is y minus f of a. And we'll plug in the value of a, so y minus f of 4, and then equals f prime of 4 times x minus 4. All right, and all the values that we need to plug in, we've already calculated them. F of 4, that's 1 over 4. And the derivative that we just went through, f prime of 4, that came out to negative 1 over 16. And if we just write down a simplified version for the equation of the tangent line, we get y minus 1 over 4 equals negative 1 over 16 times x minus 4. And that is the equation of the tangent line for this function at the point where the x-coordinate is 4. All right, this was a little bit of work. A lot of Calculus 1 students in the beginning of their calc course kind of struggle with this work. Definitely take your time with it, and you'll be able to get through it. Next up, let's go ahead and see what the work looks like applying the second version. For the second version of the limit definition of the derivative, all the work is again in step 2, where we're subtracting fractions with a different denominator. Now, we have some of the work already, f of 4, that's f of a, so we're going to jump straight to step 2, f of x minus f of a, so f of x minus f of 4. F of x is simple, 1 over x. And f of 4 is also simple, 1 over 4. And this is where the work is slightly different between the first part and second part. We're still going to combine these fractions using a common denominator. But now, the LCD that we're going to be using is 4x. So let's go ahead and take the first fraction, 1 over x. And to get that LCD, we would need to multiply and divide by the missing factor of 4. And then the second fraction, which is minus 1 over 4, we would multiply and divide by the missing factor, x. All right, and what you should find is you now have a common denominator of 4x. And we can subtract by subtracting the numerators. And it looks like we get this. The denominator is 4x. And if we subtract correctly here, we get that numerator, which is 4, positive 4, minus x. All right, now think for a second. You always want, in step 3, when you divide by x minus 4 for this problem, you want things to cancel out. You want that factor of x minus a, x minus 4, to cancel. And the factor there in the numerator looks backwards. So let's go ahead and simplify it by factoring out a negative from the numerator. So I'll write that as negative 4 plus x. And just to make it look a little bit more obvious, we're going to switch the order of addition in there. Just be careful. Whenever you factor anything out, you can distribute it back in to check. And if you distribute the negative in, you'll get negative times negative 4, positive 4, and then negative times x, negative x. So that works out. Now let's just go ahead and switch the order of addition into parentheses. And we'll write that numerator as negative x minus 4. And it's worth pointing out, when you add a negative, that's the same thing as subtracting. All right, that's the work for the question. We can now go to step 3, dividing by x minus a, dividing by x minus 4. And since the function is a fraction, we're going to use a tip that we introduced in the video linked down below in the description. Instead of dividing by x minus 4, we're going to multiply by the reciprocal 1 over x minus 4. And what we multiply by the reciprocal is the result that we just found in the step above from step 2. So we had that simplified as negative times x minus 4, and then in the denominator is 4x. And again, the reason why we're doing this, instead of dividing by x minus 4, we're multiplying by the reciprocal. That's because it's going to make the work a little bit more obvious that you can cancel the factor of x minus 4 out there. Had you not done that, and you just took this, which is a fraction, and then divided by x minus 4, you'd get a big mess of fractions within fractions. And that tip, multiplying by the reciprocal instead of dividing, that's going to eliminate and avoid that. All right, at this point, we get a simple fraction here. Looks like we have negative 1 in the numerator over 4x. And that's it. That is fully simplified. We can now go to step 4, which is taking the limit as x approaches a limit as x approaches 4. And we just use the result of what we found in the previous step. That's the expression we're taking the limit of, negative 1 over 4x. And at this point, that step right there, the indeterminate form cancels, so we can just evaluate this limit by plugging in x equals 4. And we get the same answer for our derivative. Remember, we wanted to get, like from the first version, negative 1 over 16. Plug in x is 4, and you get negative 1 over 16. And the work is slightly different. If you apply the second version, this trick here where we factored out a negative to make the factor look a little bit more obvious with the factor that we're dividing by, that's a very common tip and trick that you'll be using if you use the second version. All right, I hope you enjoyed this problem. If you're enjoying the content and learning a lot, support the channel, like and subscribe.